In class, we've talked about how the calculator is preset to do log of base 10. It does that because 10 is the most common base, especially in science classes where you do applications of logarithms. But today we'll look at what if we're trying to calculate something that isn't base 10? How can we use our calculator to tell us the answer? Let's consider log 583. Remember, a log asks for the exponent. So this is asking us what exponent on 5 will give us an answer of 83. So our calculators are set to use base 10. So how can we use a calculator to work with a base 5 when the answer doesn't work well? And by not working well, I mean that 83 is not a nice power of 5. If it was log 5 of 125, we'd know the answer is 3 because 5 to the exponent 3 is 125. So 83 does not work well. The first step is to interpret the log notation. So remember, log is asking us for the exponent. Log 583 equals an unknown is 5 to that unknown exponent equals 83. So I'm going to let it equal y. It doesn't have to be y. It could be any letter x, a, or any other letter you wanted, but I want an unknown or a variable there to hold the place. So interpreting the log notation means write it in exponential notation. We work with base is 5, exponent is y, answer is 83. So that becomes 5 to the exponent y equals 83. Now I have an equation that I can work with both sides, and as long as I do the same thing to both sides, I maintain the equality. So I'm going to log both sides base 10 because that's the base my calculator is trained to do. So I get log of 5 to the y equals log of 83. Now we have a law of logarithms that says when you're logging a power or something with an exponent, that exponent can come down in front. So we'll bring the y down to get y times log 5 equal log 83. Now to get the y by itself, we'll divide by log 5. So y becomes log of 83 divided by log of 5, which you can use your calculator to do because now we're talking base 10, and we get an answer of 2.75. So 5 to the exponent 2.75 would be close to 83. It's not going to be right on because we did round, but it will be close. Let's take a look in general now, so working just with letters. So if I have log bx equals y, that becomes b to the y equals x, base, exponent, answer. Log both sides base 10, so you get log of b to the y equals log x. The y comes down in front because of our law of logarithms, and we divide to get y is equal to log x divided by log b. Now, another way I like to say this is if you look at the original log notation, b is our base and x is our answer, y is the exponent. So to find the exponent, it's log of the answer divided by log of the base. So log answer divided by log base. And we can do that to quickly get the answer to some examples. So if I have log 12, 8, what exponent on 12 will give me 8? Well, 8 is the answer, 12 is the base. So I do log answer divided by log base. Log 8 divided by log 12, and my calculator gives me 0.84. Log root 3 of 92 is asking what exponent on root 3 is needed to get 92. 92 is my answer, root 3 is my base, so I do log 92 divided by log root 3 in my calculator to get 8.23. So your homework for this is from your textbook, page 494. Take a look at questions 9, 10, and 13.